Welcome everybody to the first Astronomy Answered session on the topic of the project GOTO. So we hope this short video will give you a brief overview of the GOTO project and hopefully prompt some of your questions. GOTO is a network of robotic telescopes with sites in the Canary Islands in Australia, which you can see on the right hand side. And the GOTO stands for Gravitational Wave Optical Transient Observer, and the project's primary objective is searching for optical bursts from gravitational wave signals, the elusive kilonova. The GOTO telescopes each hold 8 40cm Newtonian tubes with their own camera, focuser and filter wheel. The tubes and mount were made by Acer in Austria, and the cameras are from FLI in the US. Although each camera has coloured filters, GOTO normally observes only using a wide Barda L filter in order to let as much light in as possible. Each tube is looking at a neighbouring part of the sky, and together the full array can image 44 square degrees in a single shot, big enough to cover entire constellations, as you can see in the Southern Cross on the right hand side here. While observing a much larger area than most telescopes, it still takes just over 1,000 GOTO observations to cover the entire sky. On a normal night, the GOTO telescopes will carry out an all-sky survey, systematically taking 4 images of each patch of sky before moving on. Between the two sites in the northern and southern hemispheres, the entire night sky is imaged every 2 to 3 days. This of course is very weather dependent. The GOTO Sentinel system receives alerts issued by several different astrophysical observatories, including the LIGO gravitational wave detectors, the Fermi Gamma Ray satellites, and the IceCube neutrino detectors that you can see on the right hand side. When an alert is received, the central scheduler will direct the telescopes to observe that patch of sky. The entire process is automated. Each telescope has a pilot control system which receives targets, controls the hardware and monitors the weather at each site. Once images are taken, they are immediately transferred back to the archives at Warwick University in the UK for processing. At Warwick, the computing centre, our data analysis pipelines remove defects and instrumental signatures in the GOTO images using a series of calibration images, and you can see an example on the right hand side here. Each clean science image is then matched to a template image of that same patch of sky, allowing us to find new sources via the difference imaging technique. Real difference images always contain lots of spurious bogus detections, but sometimes also astrophysically real objects, which need to be automatically labelled. We use machine learning models to make real bogus predictions, but models can have difficulty distinguishing some detections, such as the one at the bottom of this discovery image of supernova 2024 GGI, also discovered as GOTO 24 AGI. Humans are better at correctly identifying ambiguous or unusual detections that the model hasn't seen before. And this is where you, as citizen scientists, can help the GOTO project by finding new discoveries in our data and helping to further improve our models. Candidates are uploaded to the Zooniverse every 15 minutes by a custom pipeline. We look forward to answering any questions you might have on GOTO and how it works, and we hope to see you all on the talk board soon.